Hello and welcome to my course Azure DevOps and Continuous Delivery with Git. I'm your instructor, Trevoir Williams, and I'm a software engineer and lecturer. In this course, we're going to be exploring the fundamental concepts behind Azure and DevOps principles. In this course, we're going to be looking at some of the key features like Azure boards where we deploy or set up rather our work items. We're going to be looking at building pipelines. We're going to look at repositories and different policies that we can implement around our repositories, how we can implement test plans to make sure that we are properly and thoroughly seeing all the bugs and reporting them, and Azure artifacts as to how we can manage all of the assets being used in our projects. So with all of that said, welcome to the course and let's get started. Hey guys, in this lesson, we're going to be signing up for Azure DevOps. Now to get to this website, the easiest way for me would be to type in dev.azure.com, and that will actually lead you to this page where it's really azure.microsoft.com/your code for your language services/DevOps. So there are a number of ways. The easiest way probably is a Google search for Azure DevOps, and then you follow the link that, of course, looks the most legitimate. So once here, you can start free, which would lead you down the path of creating a brand new account, probably a live account. If you already have one, then you can always just sign in and you can always get started with your GitHub account. So I'm going to sign into Azure DevOps as I already have a live account that I'm going to be using. This is the one that I use for my Visual Studio and every other Microsoft service that I use. Now, once here, you can see some of the projects that I've worked on. So once you're logged in, you may not see a dashboard like this if it's your first account or if you've never used it before. That's no problem. But what you'll notice is that you have an organization probably in the same name as your account or your live account. Now, an organization pretty much represents a collection of projects for an entity. So you can see here that I have a number of organizations tied to my single account, and I can actually switch between them as I am demonstrating here. And with each one, you would see a different set of accounts. So this Trevoir is actually like my personal testing account that I do. I've done a lot of experiment projects on. And then I have Trevoir Williams, where I have a further mixture of personal and academic projects. So to start a new organization, you just need to click new organization, and you actually would have probably gone through all of this before getting to the screen that I just showed you. So you would have to select, okay, which directory. So if you know about Azure, then you know that they use Active Directory, or they have their own version of Active Directory. You can actually switch between directories, especially for organizational accounts, right? But here I'm using my personal account, and then I can give it a name for the organization. So for this one, I'm going to give it the name for the course, right? So continuous delivery dash course, that's what I'm calling it. I can choose a region that would be best for me. And when I'm usually using Azure, I choose East US based on where I am, but I'm going to go ahead with Central US as that is the best option in this situation. And then of course we go through our captcha. And once we've done all of that, it will take some time to go ahead and spin up that organization and then redirect. And the end result of that will ask us to create a project to get started. So I'm going to create a school management system. That's what we're going to be working on, or at least that's the project example that we will be using as we go along, showing how continuous delivery works. So school management system, no description, and I'll be using Git for version control. Now, Azure DevOps supports two versions of, or two technologies for version control. Git, which is standard vanilla Git. This is very similar experience to what you would have gotten through GitHub if you've ever used GitHub. But if you are familiar with Git in general, it is a very similar experience when you use Git through Azure DevOps. The other one would be Team Foundation version control, which is a webified version of their very popular Team Foundation server that has been their flagship version control engine for years. So the difference between the two, well, technology. One is a centralized source control management system, which is TFS, and the other is distributed, which is Git. And since a lot of industries are showing preference for the distributed version, I'm sure that's why Microsoft has made sure to give us that offering also. So we can go ahead and proceed with Git, and then you can choose your work item process based on your natural flow as a project team. I'm going to continue with basic, and then we can just go ahead and create project. So that all of those settings are unique to the project. It's not that the organization is going to be fixed to those settings. It's just whatever the project requires, that is what will be presented to us. So once we've done all of that setup, we have our project created, we are led to this screen, right? Now, if for whatever reason you had a different experience and you are in your organization and you want to create a new project, then you could go to new project, at which point you would ask the same questions and then allow us to proceed and be able to view the project here. So once you are looking at the organization dashboard, you can see all of your projects. So let me just go back to one where there are multiple projects. And with each one, you'd be able to see all the resources, all the work items, the code, everything relating to that particular project. However, like I said, for this course, we'll be proceeding with this new organization. And when we come back, we will take a general tour of the tools that are afforded to us through our new Azure DevOps dashboard. All right, guys, welcome back. So the last time we were here, we created our account, we set up our first project in our new organization, and we really want to start looking at the tools. But before we do that, I want us to look at the organization and briefly discuss how having this organizational construct helps us to accomplish our DevOps ambitions. So the tool is named Azure DevOps, which means that it is a tool that is designed to facilitate DevOps. Now, DevOps is more than just technology because, yes, with the buzzword and the new technologies, and we started hearing about Docker and serverless and all sorts of automated this and continuous that. Before I get into all of those things, let's look at the fundamentals of DevOps. DevOps is a way of thinking. It is not just a bunch of technologies and developers doing different things. It's a way of thinking, and that way of thinking has to permeate in the organization that it is being implemented in. So before now, or before DevOps was really a thing, or what led to DevOps being a thing, was the fact that everybody worked in their silos in an organization. So somebody would say, oh, I need this new feature. Somebody else would approve it, and then they pass it down to IT, and then IT just comes under pressure because they're saying, where is it? Why can't I get it? Whereas IT is trying to fend for themselves, trying to write code, trying to manage infrastructure, trying to probably do some resource requirements, gathering, etc. So nobody really understands what IT is going through, and IT probably didn't really understand the reason for the request. DevOps is different, or brings a different way of thinking, because it's going to have everybody involved. Everybody has a part to play in the delivery of this request. So you have resources from different departments all collaborating and seeing the progress and understanding each other's struggles and helping to alleviate what they can, where they can, as quickly as possible. That is the concept of DevOps. So within the organization that we have set up in this new tool, we can actually go ahead and invite other people, right? So here it shows that this is the name of the organization. We can give it a description. We can set up our time zone. This shows an organization owner, and the organization can be deleted. I can look at all the projects that are involved and create a new project if needed. I can manage my users. So I can add users, and these users, of course, would be like different stakeholders, even different developers, anybody who needs access to the organization or the projects in the organization, etc. All of those persons can be added here. So I can actually add a basic user, a stakeholder, or a Visual Studio subscriber. Now, here's where we kind of take a step back and discuss costs and obligations. So this is the cloud-hosted version of Azure DevOps. There is a version of it that you can actually have hosted locally in your enterprise company setup, and it would be, well, I mean, whatever licensing agreement you have for that, you would govern it by yourself. This is the SaaS version of it. So I can use it for my personal use, and this organization is really just a representation of what a company could look like. A company would be able to subscribe to it and use it accordingly, at which point, based on their size, they would definitely have certain restrictions or allowances that you probably won't have as on the personal level. So when it comes to adding users, we can add a basic user and we can get up to 5 users, and they will have access to features like source control, version control, and tools for agile and build release. The stakeholders, those would be able to work with like the backlog items and queries. They probably won't be able to get into the code and all of those things and build and pipelines and so on, but they can come in and see work items and interact with, progress reports, so to speak, and make new requests. And then we have Visual Studio subscribers who basically get the whole shebang, but obviously those are more enterprise level subscribers, so they have access to other things like Azure test plans and some other features that the basic users won't get. So right now we're acting on community. We don't have those features, at least not in this particular course or tranche of the lesson, but it's good to appreciate what allowances and restrictions there are based on how you add your users. We can also go through billing. We can set up global notifications. We can view auditing to see who has done what. We can manage our Azure Active Directory. We can set up custom agents for build pipelines and pools. We can set up deployment pools. There are a number of things that we can do at an organizational level, right? So that when persons come in to the organization or join a project, each project will just adhere to the settings here, all right? So those are little things that we can do with our organization. Now, when we come back, we'll start looking at the different tools afforded to us in the dashboard when we have our project up and running. All right, so when it comes on to the project, we can go to some global settings here. So I can go to manage services. So here I can go to the different aspects which are also found to the side. So we'll be going through those in detail and one by one. But if I just go to manage your services, behind here I can manage things about the project. I can manage the name, I can put in a description. All right, so let's continue scrolling. We can change the administrator or add administrators to this project. We can turn on and off the different Azure DevOps services that we may or may not want, and we can ultimately delete. So if you look through, you see that you can also manage teams. You can manage the permissions for the persons inside of this project, right? So we would have added persons at the organizational level, then we can actually manage who can do what within this particular project. We can manage our notifications. We can connect to our GitHub, right? So we can actually link commits to our GitHub repository. Let's say GitHub is where you're doing the actual source control management. It is not that you have to migrate the repository to DevOps, but you could use DevOps as the management for your GitHub project. So it's very easy to connect your Azure DevOps to GitHub. You can set up different configurations. I'm not going to sit here and go through each one by one, because some of them you may interact with, some of them you may never have to interact with. But the point is that you have all of those options available to you. So I can just go back to the dashboard, and if I ever need to revisit it, let's say this style looks differently by the time you start checking in and doing all sorts of amazing things, you just go down here to project settings when you want to modify those settings, and you can always collapse that sidebar or expand it as needed. All right, guys, so in this lesson, we're going to be looking at the repos tab. So let's jump over to repos. And from here, you can see that I don't have any repositories. I have nothing, right? So it's telling me that one I can clone to my computer. If you've ever used GitHub, then you know that these options are pretty much what you would see on GitHub anyway. So I can clone to my computer, meaning I probably already have files up here, or I just want my computer to create a space that would synchronize with a repository that is up here on the cloud. I can also clone using Visual Studio Code or any of these tools that have excellent plugins for Git integration. Note, not for Azure DevOps integration, but for Git. So Azure DevOps is just providing regular Git services that we would know and love from GitHub and other Git providers. So any of these tools that support Git, including Visual Studio Code, could be used to just facilitate that clone. Otherwise, you can use your command line if you so desire, or you can import a repository from somewhere else. And if we were to explore that import option, then you'll see that you could choose which repository type it is that you want to import. So whether it's a Git repository or a TFVC or TFS, if that's the expression you're used to, Team Foundation, you just choose which one. All right. So if it's Git, I could actually just put in like a GitHub URL right here, and it would just import it from GitHub for me. Otherwise, I can go ahead and initialize a main branch here on the cloud. I can add a README, and I can also choose which kind of git ignore file I would want. So based on the type of project that I'm about to work on, the git ignore file, if you're not familiar with it, basically tells Git that when you are pushing and pulling, when you are checking in or updating files, ignore these particular files. So you'd usually want to use that for like certain configuration files. You know, when you're working in a team, maybe you're using different connection strings or different connection values. You don't necessarily want that mess where I'm checking in my connection values and then you can't run and then you have to update and then back and forth, right? So if we're going to be using Visual Studio for our project, we can just choose the Visual Studio git ignore template. And then I'll just click initialize to get it started. So out of the box, I get this README file, right? And I get this git ignore file. So the git ignore file, like I said, will specify certain types of files. So here it knows that anything with these extensions, ignore those. And as you scroll, you see other ones. You can go through them and see what exactly it's saying it should ignore for the different project types that might be coming from a Visual Studio based project. Now, one thing to note is that with Git, you have all sorts of things you can do. You can clone, you can fork, you can create branches, you can do pull requests. And if all of those sound foreign to you, don't worry, we're going to be going through them. This is just an overview of what's available to us. So from here, I can actually create other repositories. I can create a new repository in the same project, right? So I could say that this is maybe SCM-test, right? School Management System-test. I can do the same thing with the git ignore, and then I can create. So now I have multiple repositories inside of the same project, logical project in Azure DevOps, and I can switch between them relatively easily. So you see, I could do that from here also. I could create a new repository, import one, or manage, meaning I can now go and say, okay, I no longer want SCM test. Let me just delete that one. And then just to make sure that you're sure, they give you a very deliberate activity to retype the name, and then it can be removed, right? Because they don't want you to make any mistakes, right? So they want to make sure that you're sure that's what you want to do. So I can just switch to the default school management system, Scrum. So while I'm here, let's make some edits. I just want to show you how Git helps you to keep track of what is happening on your project, right? So if I go to the README file and let us say I edit, and I can do certain edits. I can do basically edits to any file once I'm in the repos tab looking at the file. I can always edit, right? So if I wanted to add another dash, maybe to say Google, whatever it is, and then this supports Markdown. So if you are familiar with Markdown, then you realize that the hashtag here represents an H1 tag pretty much, and the hyphen represents a bullet point, right? So if you're familiar with Markdown, then you'll feel right at home with this. So https://www.google.com, right? So I've added that new URL, and then I can just say commit. So with each commit, you want to include a comment that gives guidance as to what changes you made or what is different about the code that you are contributing, right? So you want to put in a comment. You can also specify a branch. So the branch is generally main, right? Remember when we were creating it said create a main branch. There it is again. In the past, this used to be called master. So, if you see master, it's pretty much the same concept as main. And then I can associate this with any work item. So that way I can keep track of the work that has been contributed even by a particular user or, team member relative to the actual task that is being done. So if I said testing tasks, right? And probably the work addresses more than one tasks also. So that's fine. I can just commit. And you see here, it is committed. So if I click on that commit, it will show me what was different about this version of the code or this version of the file that was actually committed and who did it, what changed, right? So Trevor Williams committed just now. I can look at the details to say this is who authored it, committed it, pushed it. I can look at the parent, where is it coming from? I can look at the associated work items with it. And I can even browse all the files that would have been in that particular commit. So when I look at all the files at this point, I can see that this one was updated just now with that commit by that person, right? Once again, history would show a graph of all the commits, any branching that might have happened along the way, and all of those things that are generally going to happen during at least a team exercise of building out a project. You can use this graph to see every single commit and change that was made. We also can enforce like branching strategies, branching policies, enforce pull requests. We'll be looking at those things later on though. So if we continue with the tabs, we see commits. We just saw the commit graph, right? So this is just a dedicated graph for the commits for that repository. We'll see all the pushes. So the difference between a commit and a push is that I can commit the code, but pushing actually puts it into the source code, right? So you could have like policies to say that, you can't just make commits or you have to meet certain criterion before it can be pushed into the main branch or into whatever branch. So that's the difference between a commit and a push pretty much. We can look at the branches. So here I can set up a branch. I can create a new branch if I need to. So I can go to new branch, and generally speaking, you would want to create a new branch for new pieces of work, like new features, right? So if I am developing a new feature for the school management system, I wouldn't want to create it directly into the main branch because my new feature might have some breaking changes, some schema changes that we're not quite ready to have in the main source code. And you also want to vet it before you put everything together. So you would create like a feature branch. So like the parent portal would be a feature branch. And then you could say, okay, it's saying, sorry, no space, right? And then you could say it's based on main. So you could base it on other branches if needs be. So we'll leave it on main. And then you could associate it with a particular work item. So then you say create. And what a branch does is make a copy. It makes a copy of whatever branch you based it on. So whatever the source code looked like in that original branch is going to take a copy of that and put it in its own copy. And now you can work against this copy of the main branch in this case, right? And you can have as many branches as you need to for features. Of course, your scrum master and your seniors would determine how that branching strategy works in the long run. So let us work through this branch. So we created this branch parent portal. I'm just going to create a quick edit here. So I'm just going to click on the README, edit, and let's say I'm just going to put the text down here, hashtag before hashtag, so that's like H4, working on the parent portal. So let's say that this is what I'm doing. I would commit added parent portal work, right? So I did all of that. I could assign it to a task once again. So I'll just put it to testing tasks and commit. Now, once we've committed, we get the option to do a pull request. So a pull request would be like a code review, right? So TFS actually, or TFVC would actually call it a code review, where it would send my copy of the work to whomever, to the team, whatever the policy is, but whomever would be doing the checks before merging the code, that they would get the pull request. So I'm going to create a pull request, and then I can put in the title, the description, any other features I want. I could request a review from that particular user or users, and then I can just go ahead and create that pull request. So then it's going to check to make sure that there are no merge conflicts. So merge conflicts would usually occur like if maybe the file I edited would have, I would have changed something that is on a particular file, and by the time I'm doing this pull request, it's different in the main. So that means the main went left and I have gone right. So there's obviously going to be a merge conflict. So it would highlight to me that, hey, you know, based on the files in this pull request, the edits in this pull request, they would conflict with the files from the original branch at this point. Please make sure that there's no issue. That usually happens if two persons edit like the same line in two different versions. In this case, I've made my changes and it sees it as just a change. There's nothing there that's conflicting with it. And at that point, I can just go ahead and I can add new reviewers. So I could add another optional reviewer or somebody who is required. And at any rate, I can, as the reviewer, approve with suggestions, say that I'm waiting, reset, etc. Or I can just complete, abandon, or mark it as draft. So abandon would be like canceling the whole thing. Maybe I realize, oh snap, I didn't do this, let me cancel. Completing though would be requesting now for the merge. So I can choose different merge options, right? So in merge, it will preserve all the commits. So you would be able to see all the branches and every bit of work that was done against a branch until it merged into main, because I can have multiple commits on my particular branch without doing the pull request. The pull request is when I'm saying I'm done with my branch, please accept, right? We can squash, so it will only do one commit on the graph history, and then you have rebase and fast forward and semi-linear merge, right? Not going to get into the details of those two, at least not yet, but let us just complete merge. So when we are completing, we can say complete the associated work items after merging. So this would be used to indicate that the piece of work that's being merged addresses these work items. I can also remove the branch afterwards, because then that would signify that this feature is about to be implemented. I don't need to work on a separate copy, and I can customize the merge commit message if I want, so that on the timeline you can see whatever I want to say in addition to the default, right? So if I complete merge, you'll see this change and it will show you that it was completed, and you can go back and cherry pick. This would almost be like picking this specific version of the merge, and pretty much that's it. So if I go back to branches, then you see I only have one branch, and then you see that just now there was a commit, and this commit was adding my new stuff that I did in the merge request. And you see here that the comment is letting you know that it was merged and it was related to those particular work items. So if I go back to my graph, then you'll see here where it veered off to the merge, right? So the graph is going to look slightly different with each option of the merge type. And if we go back up to boards, yes, we're done with boards, but look at this now. You notice that one is missing. So if I jump over to repos, go to pull requests, and then from here I can see any that I have requested, any that's in progress, if it's abandoned or completed. So if I go to completed, I can see the related work items. So just for context, if I click on that task, I can actually see all of the commits and merges and whatever has happened around this particular work item. So I can have the complete history of the development work that has been done. I can also add a link manually to a branch if I need to, right? So there are no branches in this repository, so I can't just add it to main, right? There has to be a branch and then I can associate them. So while we are in repos, let's take a look at branches quickly. So I can enforce branching policies, right? So branch policies, I can also enforce security. So if I go to branch policies, from here, I can turn on and off certain settings. For instance, if we have like a maker checker or what they call the 4 eyes principle, a reviewer, 4 eyes should always look at the code before it gets put in to the main branch, then I can require a minimum number of reviewers, right? So require approval from a specific number of reviewers on pull requests. I can just turn that on. I can say 2 reviewers or 1 reviewer. And you can read through those as other options that you can place on that policy. I can also check for linked work items. So you can't be, checking something in without me knowing what this piece of work is associated with, right? You can check for comment resolution. So all comments have been resolved on pull requests, right? And I can limit the number of the merge type. So that means, remember, we had the different kind of merge, the one that squashes it all into one, the one that shows all the history. Based on your policy, you may want to see one and not see the other. It's not necessarily to say, oh, this one is recommended or not. That depends on your team and how you are running your project. So these are some things that you can look into when you are determining how you want to run your project, what kind of standards you intend to uphold. Of course, you don't want to put in anything that's going to frustrate the process, put too much work on you where you have to reviewing every little thing. But once again, that's up to you and the way that you're running your project. So certain things with Git would be different with the TFS engine, because if we were to create a new repository and make it a TFVC, then you would notice that there are certain things different. Like for our repos, we only have change sets and shelf sets. So a change set would be, yes, this is what I checked in, and a shelf set would be like a temporary area. So I'm not quite ready to check my work in yet. So I keep on saying check-in. So because I started off with TFS, so that's why I keep on saying check-in. So in TFVC or TFS, you check in your work. However, in Git, you commit your work, right? So when I try to commit with Git, we just saw that you can do the whole pull request workflow. With TFS, you can do shelf sets. So these are like copies of your work while you're completing your task. And then the chain set would be what you get after you've checked in to the main. So the difference between TFVC once again and Git is that TFVC is centralized. So every time you have to be communicating with this one project space, whereas Git actually facilitates a more distributed approach where each team member can have their own copy and work in their own silo and have their own Git environment. And then when they're ready, they just merge to a main Git environment. However, everybody can be kind of autonomous in their own Git world. So that's a quick and dirty tour of the how repos work and the different things that we can do with Git. As we move along, we'll be creating a project, an actual project. And while it's not a development course, we will be putting in certain things and looking at the workflow and analyzing different scenarios as the project evolves. One of the foundations of DevOps is found in the concept of continuous integration, and the other is found in the concept of continuous deployment. So you'll see those two phrases, or CI/CD, mentioned a lot by every practitioner, every source that you look at. Once it's talking about DevOps, the concept of continuous integration and deployment will always come up. So continuous integration has to do with the ability to always integrate new code and have a solid foundation or flow for your code base, right? So we kind of looked at that with the repository. So that's where source control kind of comes in. When we talk about continuous deployment now, we're talking about always being able to deploy these changes without messing up the system and creating a platform so that we can roll back should something happen. So you want to make a deployment as seamless as possible. It shouldn't be something that's scary. So that is why Azure DevOps as a tool has this feature called pipelines. So the pipeline is going to allow you to set up the rules by which any application one gets built. All right, so built meaning compiled, and it creates what we call an artifact. And then this artifact, which is the compiled version of this application or this version of the code, then can be deployed. And then we also get to set up the rules for deployment. So which server it should go to, what kind of environment it will be going into. So that takes a lot of the manual work out of having to update like a website or any kind of application pretty much. So let us look at creating our first pipeline. So we had gone through setting up a new .NET Core application in our project. So when I go over to pipelines, or well, when I'm in the repository, I can actually set up a build from right here. So setting up the build would actually bring me over to the pipelines. It will be the same thing. If I go directly to pipelines, I can click create pipeline, and then they will ask me, okay, where do you want the source or where should the code be coming from that I'm about to create a pipeline for? So obviously, if I went through going to directly to the setup build from the project, it already knows that it's a local project, use the local project. However, from this perspective, even if I didn't have anything in the repository, I could actually tell it to look at a repository that might not have been in this particular project. I could tell it go to Bitbucket. I could tell it to go to GitHub, another Git repository subversion, or Team Foundation version control. So I'm just showing you that it's not necessarily tied to having everything hosted and the source code hosted here. You might already have your active project being hosted in a third-party solution, any other Git repository, right? You could actually just go ahead and set up a pipeline for the code at that third-party location. The rules, of course, will be different based on how you connect. So, or where you're connecting to rather. So you can either select one of these, or you can go to the classic editor. So the classic editor kind of brings you through a different menu selection. So you choose a project, the repository, the branch, and generally speaking, you don't want to build on the main branch, and then you can click continue, and then you can choose what kind of template you want. So here you see all of these templates. You can start off with a YAML file, which is really just a configuration file where all the steps are outlined, or you can choose one of these other options, and you see it's not limited to .NET Core. It's not even limited to .NET, because I can build an Android, I can do Docker stuff, I can do Maven, Python, I could even do Node.js stuff, right? So it supports a number of templates out of the box, and it supports some third-party tool integration like for Gradle and Jenkins, all right? So I'm going to choose the easy way though. The easy way would just be to follow the project. So if I'm in the project, I'm just going to say setup build, and then it's going to say, okay, what kind of project am I working with? I'm going to say, okay, I'm working with an ASP.NET Core project, and then here's that YAML file. So now it's going to build or create this YAML file, which basically has certain variables and certain configuration stuff. And then we go into the steps, which basically say step number 1, call NuGet and get all of the packages, right? And then do a build to make sure that when it compiles, it's successful. And then if you have any testing, you can put that in there. And then based on your environment, you could put other steps into this YAML file, other variables, other pools, etc., and modify it as you need to. All right, so if I do save and run, then it's going to say commit message, set up CI with Azure Pipelines. It's committing because it's about to add this new file to the entire project, right? and then I could create a new branch for this particular commit, or I can just do it directly to the main branch. We kind of already explained why you may or may not want to do that. So we can do save and run. Now, what you would have seen would be the what is now a red X would actually be blue and spinning. So you're probably seeing that already, especially if you're on your organization's Azure DevOps, or you actually have a paid subscription with Enterprise or so on. But on the free tier, they have to assign agencies. So this failed. And then the error here is saying no hosted parallelism has been purchased or granted. So to request a free agent, please go through that form. So I actually brought up the form here, and it's letting you know that it could take 2 to 3 business days to proceed with the request. So I would advise you, if you're getting this error, go ahead and sign up and then leave it alone for 2 to 3 business days, and then we can revisit it. But in the meanwhile, let us read up on what this is. So they said, learn how to estimate how many parallel jobs you may need or need to buy for your organization. And then they're saying here that we have temporarily disabled the free grant of parallel jobs for public projects and for some private projects. However, you can request this grant. So that's actually in newer organizations. So because we're just creating this organization, chances are you are going to go through this. And if you read up on Microsoft hosted versus self-hosted, you'll see here that for the Microsoft hosted parallel jobs, you can get up to 10 free ones that can run up to 6 hours at each time for public projects. When you create a new Azure DevOps organization, you are not given this by default. So, like I said, go ahead and fill out the form and then give it some time. Later on, we will be looking at creating self-hosted jobs where we can register any number of self-hosted jobs, and you would get charged based on the number of jobs you want to run at a time, as opposed to the number of agents. So there are no time limits on self-hosted. For public projects that are self-hosted, you have unlimited parallel jobs. You can have unlimited parallel jobs running. All right, guys, so some things that you want to change, or you may want to change. Firstly, let's go to our organization settings. We can change the visibility by going to policies, and you can allow public projects. So in our case, for educational purposes, you can enable that. Of course, if you're doing this in an organizational setting, you don't necessarily want that kind of public exposure. Another thing, though, is at the project level, you can always go to project settings, and you can always change the visibility from public to private and vice versa. So if it's private and you want to make it public, once again, for educational purposes, you can always make it public. Then you can also look at the parallel jobs. So when you come to parallel jobs, you see here for private projects, there are 0 jobs associated with that, and 1 self-hosted. But then if you look at what self-hosted means, it means jobs that run on machines that you manage. So that is why we wouldn't have it in the cloud offering. And then jobs that run on a pool of machines hosted by Microsoft, which is what we would want for the cloud offering, right? And then you can always go ahead and make a purchase if you so desire. And then for public projects, we still have 0 jobs, and then we can have unlimited parallel jobs if we want. So after you've been granted approval, when you refresh this same page, you will now see that you have 1 parallel job in the free tier, and you're given up to 1,800 minutes per month, which is more than enough for a private project or for demo purposes. But of course, in a corporate setting, you'd want to go ahead and purchase so that you don't have those limitations. Now I'm going to remove the existing pipeline, and I'm going to start that whole process over. So you see here that they're always making sure that you're sure and deliberate when you are removing stuff. All right, so let's go again. So what we're going to do is create pipeline. This time I'm using the pipelines screen. So I'll create pipeline, and then we can just choose the Azure repos Git. We already discussed all the options that you have available to you. So I'll choose that one, choose our repository, and then we have the YAML file. So this YAML file is designed to run with the type of project that you have, right? So if you're using a .NET 5 project, it would automatically be able to decipher that you're using a .NET 5 project, and that is the type of build it should do. So all the steps are outlined relative to a .NET 5 project. Now, at this time of recording, the .NET 6 SDK is not fully supported by Azure DevOps, meaning the default steps would not work with my .NET 6 repository. So I actually had to go through and modify this YAML file and then put in steps so it would know that it should be using the .NET 6 SDK and not defaulting to the .NET 5 SDK. So if you're using a .NET 6 project, then you will want to do what I'm about to do. If you are not, if you're using .NET 5, .NET 3.1, it would automatically support that by virtue of what is supported. So first of all, we look at the trigger. So you can actually always modify this file. You can introduce variables. You can do a number of things. So I'm just going to take you step by step. And when you're at this point, you can just modify as we go along, or you can clear out the entire file and just replicate what I have. Firstly, back in the day, GitHub used to call the main branch master. Now it's called main. Sorry, Git used to do that. Now it's called main. So I'm saying here that trigger this build whenever there's a check-in on main. So you can actually have different builds against the different branches, because it could be that you have a QA branch, a dev branch, and a production branch. Main would generally be like your production branch, but you want a different build or set of build steps for the production branch than you do for the dev branch, etc. So that is why you would have that trigger and you would give it the branch name. So I'm saying main branch, right? Pool, VM image, I'm using Windows-2022. Then for the variables, you probably already have the variables, so you probably don't need to change those, but you can if you need to. Then we can move on to the steps. So the first step is to choose the SDK. And if I hover over the task, it will actually tell you use .NET Core. It acquires a specific version of the .NET Core SDK from the internet or local cache and adds it to path. So I'm saying go ahead and make that acquisition. Display name is what the step appears as during the whole build process. So when we look at the logs, you'll see that you would have seen a preview of it, but now we're putting in our own steps. So it will become more clear to you what is happening. So basically, this is just for human readability. This is what is happening at this task, right? Just give it a name. And then for the inputs, I'm saying that the package type, and the thing is, as you type, you notice that you actually get hinting, right? So for each type of task, you can put in different kinds of inputs, right? Based on what you need to do. So package type is SDK and the version is 6.0.x. So it will support builds in between, right? Then we go on to say add a command line to go ahead and check against all the .NET SDKs that are in there. So at least we can see a visual representation. And once again, you could also give it a display name. All right, so I don't have one here, but you could if you want to. There is no NuGet installer actions carried out. So the task is there, but okay. And then the task for the NuGet command, we just restore the solution. And then we have the VS build. And then you can go through all of that and VS test. If you have tests, then you would have a bit more happening under here for the unit tests. I don't have any tests, so I don't have to prioritize that. Now, I have added a sample of this YAML file to GitHub gists. So gist is just a quick way to store like single files, and you can use the link that you see here. You can just go to my profile and look for that file accordingly if you so desire, right? So that is where you can get that pipeline and you can copy and paste if you really don't want to write it out manually like I'm doing here. Either way, once you have that file in, you can go ahead and click save and run. And remember that we're going against the main branch, so any commit to the main branch is supposed to trigger the build. So just by adding this file to the branch, it is going to save the changes, do the commit, and then it's going to trigger the build. So coupled with our newly created parallel job and our refined pipeline, we can give this a few seconds. And you can actually sit and watch as the steps get filled out and completed. So like I said, each step here, if you give it a display name, you would be able to do the human readable version of what is happening at that particular step, versus no step name where it's just going to give you the default name. So if you want, you can go back and add your own display names. You can always modify that YAML file as you need to. So just give it a few seconds and let it go through the steps. And all green ticks is what we want to see. So every step of this operation was completed successfully. So if we go back up to our repos, we'd be able to see that we had a successful build from the pipeline, right? So like I said, any change that is made will trigger a build. So let us say that we made a modification here, and I'm just going to edit, and I'm going to say added build pipeline. That's all. And then I'm going to commit. And once I commit, and do notice that you can always add your work items here. I think I would have mentioned that before. So let's just go ahead and do that commit. And what you'll notice is that if you go over to the pipelines, it is now queuing up another job, right? So it's now saying that, okay, there's another change. Let me go ahead and do another build. So that's how you can kind of protect your source code to make sure that code that wouldn't compile isn't being introduced to your branch. Because there are times when, as developers, we might inadvertently add a line of code that really didn't build, or we did a build and then we made a change and then we didn't build again locally, so we try to check it in. Well, this is going to try to compile everything and make sure that it works before it even commits it into the source code. So that's the basic set of steps towards setting up a build pipeline. It may have taken a few more steps than you would expect it to, because we had to go ahead and apply for our build agent and be able to run the job. But that's just a part of it being free. When we come back, we will now start looking at release pipelines and environments, and then we'll just take a look at the other options available to us under the pipeline section. All right, so the last time we were here, we were looking at pipelines, and we set up a successful build pipeline for our project. Now let's look at the release pipeline. So when we click on releases, we can add a new pipeline. Our release pipeline pretty much would hook onto the build pipeline and allow you to deploy your app to an environment. So the Azure DevOps tool would already know that based on the type of app, based on the type of environment, these are the things I will need to do to compile it so that it can be production ready or ready for use. So what you would notice is that they have a bunch of templates, just like with the build, but you have a bunch of templates that allow you to select what kind of app you are working with, or you can just do an empty job and start off with your own steps. Once again, that would kind of allow you to go stage 1, stage 2, stage 3 if necessary, right? So first of all, I need an artifact. An artifact would be the compiled version of the website. So I can click add an artifact. That is going to say, okay, where am I getting this artifact from? I can say I want it from this project, and the source would be from the build pipeline. So in other words, anytime you complete a build, you are supposed to produce an artifact, and then you are supposed to use that for the release. Now look here, no version is available for this, or the latest version has no artifacts to publish. Please check the source pipeline. So that's no problem. So that means I have to go back to my original pipeline and make sure that it is producing an artifact. So if I click on the pipeline, or I can just use the 3 dots, go to edit, I will see my YAML file. And what I did not do at the end of these steps, right? Task 1, task 2, etc., is publish an artifact. I did not do that, right? So I'm going to go ahead and do that. So earlier, I didn't point out or bring too much attention to the fact that you actually have the tasks outlined to the right-hand side. So if you don't want to type everything manually and you might not be familiar with the YAML syntax, and that is completely understandable, then they have the tasks to the right. So if I wanted to add the task to publish the artifact, I could just search for publish, and then you'll see here that I have a number of options. But the one that I really want for this particular situation would be to publish the pipeline artifacts. So just by clicking in the document where I want it and then clicking it, it will introduce a new task with the name publish pipeline artifact at sign 1. So that's basically the version of it, right? So it will publish or upload a file or directory as a named artifact on the run. And then it takes the inputs and it will set up everything for you. I think the only thing you have to put in is the name of the app that you want. So I think once you click it, let me just refresh myself, right? So publish pipeline artifacts, you can leave everything else default, but you just give it an artifact name. So you could call it web app, you could call it app. I called mine school management app accordingly, right? So after that, you can save it and then you can run the pipeline again. So it will recompile, and then at the end of it, whatever it has compiled, it will publish an artifact or compiled version of it. So when we go back to the releases and say new pipeline, we can, let me just click off the templates. If I go to add artifact, I will now be able to see that build once again, and then the message will say that the artifacts published by each version will be available. The latest successful build of that project published the following artifacts by that name. So I can add that artifact. You can also set up a schedule. So you can say schedule. Well, it starts off as disabled, but you could schedule releases. So like this is what we call the continuous integration, or having like a daily or weekly build. So, you know, developers might be introducing new things ever so often. You want to keep a particular environment up to date with whatever it is the development team may be doing on a daily basis. So you can actually schedule that 3 a.m. every morning. The release pipeline will run, even if there is no build to necessarily trigger it, it will run automatically, and it will deploy whatever the latest build is to whatever environment you want. So you can actually do that. All right. So I'm going to disable that for now though. And what I'll do is add the stage. So I can add the stage 2. So first the artifact, and then we set up the stage. So what template do I want for the release? Well, at this point, I make my decision based on what environment I am going to, or I can just set up the empty job and build it up myself. So if I wanted to be deploying to, say, an Azure web or app service, I can just select this deployment. It will know how to compile and how to set up and do everything that is needed to get it into Azure. So here you can see that the stage 3 has that one job. But what if I had multiple places I wanted to send it to? At this same stage, I could add other steps, right? So I could say, so what it does is create different stages each time I click add stage. And that is how you get that pipeline effect. So if it's a case where you have dependencies, that this one must be in the environment before that one is in the environment. Let's take, for instance, if you had a suite of services and you know that your API must be in the environment and deployed successfully before you try to deploy the web apps that depend on the API. This is how you could automate that entire process. First, deploy the web API, then deploy the web service, and then deploy whatever else might rely. So you can set up that particular order of events accordingly. Now, in that example of having, say, the API and the web app and so on, chances are they would all be in different projects on their own Git repos. So guess what? You can have multiple artifacts. So it doesn't have to be one artifact and one pipeline. It could be that this entire release has multiple artifacts. So I can add other artifacts. If I had other projects, I could just say which project, which source pipeline. And let's just say this was another one. So I'm just going to give it another name to get rid of this error. I could add that artifact there, right? If it is that this stage should have, say, simultaneous or can have simultaneous actions being carried out after this stage is done. So it doesn't have to be 1, 2, 3. It could be 1. And then after 1 is done, I could have another task that is going to be carried out accordingly, right? So I'm just showing you that when we talk about pipeline, it is literally a pipeline. It's a workflow that you are creating to show that this is how each step should flow. Now, by clicking on these little icons to the sides, we can access different options. So if I click on the lightning bolt here, I can see that this artifact will trigger the build. Well, they say build disabled. So do you want the continuous deployment trigger? This enables the trigger to create a new release every time a new build is available. So do you want that? So this is how you get that continuous integration. As soon as I check in or commit, then the build is successful, then trigger a release. Is that what you want? It could be for maybe your prototype branch, right? Or your prototyping environment where anything experimental, as you put it in, you want to see it in the environment. That might be different from the dev where everybody is working together. And that might be different. Well, that's going to be different for QA and production and pre-production, right? So based on the different environments, you would want to enable or disable the different options accordingly, right? You can also view other options here for the actual stage. So you can say, select this trigger, set the trigger that will start the deployment at the stage automatically. Is it a release? Is it after stage? Whatever it is, how do you want this to happen? You can put on artifact filters. So you can say which artifact should be used at which stage, right? You can set up the schedule. We kind of looked at that already. You can do pull request deployment, which would have the dependency on the pull request action being enabled, or the pull request trigger being enabled on the artifact. So unless you have that enabled on an artifact, you can't enable it on the stage, which is understandable. We also have pre-deployment approvals, so we can actually say that you cannot do a release until it has been approved. And we talked about that maker checker or 4 eyes principle, right? Where somebody's doing, have somebody to approve, and then you can see that you can have different policies around that, right? You can also set up gates. So a gate would be like a rule or set of rules that you can set up to make sure that these are in place before any deployment happens, right? Or trigger this action for the deployment to take place. So you could set up even like alerts to make sure that the environment meets certain criteria before any deployment can happen. You can set up compliance on your Azure. So for this situation, because I'm saying Azure Web Service, the gates might be different. So if you're doing it on an IIS server or Azure server or whatever kind of release you're doing into whatever kind of environment, they have pre-configured gates that can help you to control what the environment should be like prior to the actual deployment. So you have that, and you can also set up the queuing. So you can have the number of parallel jobs you want for the release, and you can deploy in sequence or deploy latest. You can do a number of things. So if we sat down and explored every single permutation, this course wouldn't get finished. But the fact is that you will always do what's best for your situation, and different projects require different strategies. So it's not necessarily a one size fits all. It's about seeing the options and choosing the options that are best for this particular solution for that particular setting. So let us look at the tasks. If we jump over to the tasks, we see here that for my release or my pending release to the Azure, firstly, it wants to know my subscriptions. I do have an Azure subscription. So if you do too, you could also choose that. And then you would have to authorize and make sure that you set up the roles and such between your account and Azure DevOps. And then you'd also need to provide the Azure service with a name. So those are little things that you would have to make sure are in place. You could also do this. I'll just leave. You could also set up a pipeline that would deploy to an IIS deployment or setup, right? So I can search for IIS, and then you'll see here you can just do a web deployment. You can do a number of variations of that. You could do it to Azure virtual machines. Like I said, based on the template, it will pre-configure all of these things for you. So if I choose IIS website deployment, that's my stage one, and I'll just add the artifact. So we already know that. And here are other types that I probably didn't mention before, but you do have those options. So you could actually get artifacts directly from GitHub. So you could do a release pipeline for something that is actually on GitHub without actually having the source code in Azure DevOps. It's very, very, very powerful and very integrated. So I'll just do the build, and you could also change the version, specify the version at the time of release. So this is another way you could control the version that is actually being released. But I'll just work with the latest, add that. And then if I look at these tasks, you'll see that one, I can change the stage name, sure. I can create or update the website. I would give it the website name. So default website is always the website, but in this case, I would probably want to call it like school website, school management website, something like that, right? And you just have the different settings. I can't, in this particular course, go through every single setting, but with the IIS deployment, what it will do is give you an agent that you'll need to install on your machine and give you a few commands that you will definitely need to run in order to establish the communication between the Azure DevOps and the particular server. All right. Now you see here that I have this red line here for deployment group. So before I can proceed, I have to have deployment groups existing, or a deployment group existing. So when I click on that gear, it's going to bring up another tab, bring me down to deployment groups, and then I can add a deployment group. And let's say SCM web machine. And you could specify dev, right? So create that. And here is where you get that command that you would run on that target machine. So it's going to say, what kind of machine are you targeting? And then in order to facilitate that, you can just go ahead and use. So you can use a personal access token in the script for authentication. You'll modify that script a bit. You copy this to the clipboard. You go over to the machine, run it through PowerShell, and it will do its thing to establish the connectivity between your machine, whether it's your laptop that you're using to do this course right now, or a server, or an Azure virtual machine. You can go ahead and do that. Now, once this deployment group exists, I can now specify that that is the deployment group, or the set of rules, or that connectivity that I want to leverage when I am deploying to an IIS setup. And once I have that pipeline done, I can create, and I can save, and then I can create a release. So now I have this release. When you say create release, it's actually going to trigger the stages. So it's actually going to trigger the pipeline. So let's go through that again. If I go back to pipelines, and let's say I just click on releases, what it's showing me would be the ability to create a release against that particular pipeline that is already set up. If I want a new pipeline, or if I want to modify this pipeline, first of all, I can always click edit. It will bring me back to here. I can look at the tasks, variables, retention policy, all of those, right? So this is how you get to roll back to previous releases, because retention means that I will retain every release up to whatever threshold was defined here. If I wanted additional releases, I could just click new, and I could say I want a new release pipeline, which would bring me back to this particular screen where I can give it a better name so I know exactly what this release pipeline is for, and follow through on similar steps. All right. So releases, and I didn't set up any deployment group. I'm not setting up my machine for all of that. You can experiment and do that one on your own and let me know what the outcome is. Now, environments, these allow you to sort of add some more control to where your deployments go. So I can create an environment, and let's call it dev, right? I can choose no resources. I can choose to add a Kubernetes cluster, or I can use virtual machines. So for the Kubernetes cluster, that would connect to Azure and allow me to use the AKS, which is a service on Azure, right? I could also use virtual machines, which would require me to do some registration and some additional setup. So there are a number of options that you have. For now, I'm just going to choose none and create. And what you can also do with the environment is set up certain controls over how these deployments would happen in that particular environment. So after we've created that, we can add the resource afterwards if we wanted to add the Kubernetes or virtual machines. And I can also go to security, manage who can do whatever, the permissions. Sure, we can actually do that with everything, the pipelines and the releases. But I want to go to approvals and checks. So I can say who has the ability to grant the approval for a deployment at any given point, right? And I can set up the allow approvers to approve their own runs. I can set up control options that, after this point, the approval is no longer valid. I can set up branch controls. So I can say which branch is allowed for deployment to this particular environment. And I can set up branch protection. All right. I can also set up what business hours are valid for deployment. So if you have like a production deployment, you don't want to be doing that in the middle of the day, right? So you want to set up the limitations around that. And you have other sort of controls. And you notice that some of these kind of look like the controls that were available in the releases section of the options. So those are things that you can do to kind of tighten up the environment, what branch goes to where, what artifact gets published, what steps are involved, what kind of setup needs to be there. As you can see, you have tons of options. But once again, this is more like an overview, and the decisions you make are relative to what your environment needs at the time. All right, guys, so we're starting off this section by looking at what it takes to connect to a TFVC project between the server and our computer, and how we set up a build pipeline. So let us start off by connecting our project. So if I go to repos, we know that we have our Git repos, and I also have the TFVC repository, which doesn't have anything in it. So I'm going to bring up Visual Studio on my computer, and I'm going to select clone a repository. Now notice it says that you can get code from an online repository like GitHub or Azure DevOps. Of course, it's not limited to those, but we can make it work. So we can select that. We would put in our repository location, or we can just go specifically to one of those two aforementioned platforms. In this case, we're dealing with Azure DevOps. So I'll go ahead and select that one. And what it will do is connect to our organization, to our account. Of course, you might be prompted to log in here, and then we can see all of our organizations. So I know that for this course, we're using this organization, and I see the project, and I see all of the repositories that I could possibly connect to. Of course, we're using our TFVC. So I'm going to select that one and connect. And when we do that, we are going to be presented with a few new toolbars that if you have never used TFS or TFVC, you may not have seen this. So we know about Git changes, and that is what we were using when we were doing our whole development activity with Git. In this situation, we are looking at TFVC, and we're looking at the Team Explorer. So if you are not seeing this toolbar, or you might have closed it inadvertently, you can always go to View, and you'll see Team Explorer listed there. So Team Explorer shows us our work, what is assigned to us, all of the work items on the server. We can look at the Source Control Explorer, which is what I have open to the right. We have pending changes, which would be just like when we go to Git changes and we see all of the changes that are staged to be committed. We can also look at the build history, and we can change some settings. So it's fairly straightforward, just a slightly different layout. And you would notice later on that certain things I might say, it's because of my background with TFS and TFVC, why when I'm using Git, I might use a TFS expression, but the operation is fairly the same. So let us look at the Source Control Explorer. Here, what they're doing is they're showing us our project, and they're letting us know that it is not yet mapped to our computer. So we could actually map the whole organization. We could map a project itself. And what we would want to do is find a local area on our machine so that all of the files that are on the server will be present in that folder, and vice versa. So just the same way that you see this saying not mapped, when you click on School Management System, it may say not mapped. What you do is click it, and then it will allow you to browse to the location where you would like to do that mapping. So let me just kind of show you what that would look like. So if I click not mapped, it will ask me to select the local folder, and then I can go ahead and browse to the location. So you can do that. But well, depending on your strategy, if you're by yourself and it's a one project just for this course, then yes, you can do the project. But like I said, some organizations, what they do, they have a number of projects inside of the organization itself. So they would just map at the organizational level, and then each project would have its own folder inside of that. So there are different strategies here. So for this course, click the project, go ahead and map it to your local folder. All right. Now that that is mapped, there's a direct link between the server and your computer. Remember that we called it a centralized system. So whatever happens to the server is going to happen to your machine. If you disconnect from the server, yes, you're going to have your local files, but for the period of that disconnection, there's going to be a total disconnect between what you can, certain things that you can accomplish and not. That may require the server to be present. So that is one of those pros and cons that you can work out when choosing between TFVC and Git. So let us just complete this activity by going and creating a new project. And I'm going to create a simple enough ASP.NET Core web app, and I'm going to create it inside of the location that is mapped to my TFVC. So that's my TFVC workspace, right? And I'm going to be calling this School Management TFVC just to make sure that I can identify it clearly. I'm going to keep it simple. We're just going to use .NET 6 again, leave the authentication type as none, and go ahead and create. So now that our project is created, let us say that this was the first creation. Now we want it on the server, right? So if I go back to my Team Explorer, I can go to pending changes, and from here I would be able to see what is new, what is old. So we have excluded changes, included changes, related work items. You'll start to see that a lot of things are similar between the Team Explorer and Git changes. The concepts are the same. So when I say check-in, it's because I'm used to seeing the check-in button here, but Git calls it commit, right? Same operation. We still are encouraged to leave a comment, even though I think for TMVC, it's not as enforced as it is for Git. That might be different in more modern times, but I'm just showing you that there are a number of things that are similar. Right now, however, we're not seeing the changes. That's because they're all under the excluded changes. So I can click that they have detected 77 ads, and then I can promote them, and that would be like staging the changes in Git, right? So remember, when you stage, it like creates another category to say these are definitely files I want. So included files will get checked in. Almost said committed. Included files will get checked in, and excluded files will be ignored. So if I right click one file and say exclude, then it will not be included in the check-in. So I can always include and exclude as I need to. And then I'm going to say added project files. So from here, I can do what we call a shelve. So shelving would be like, well, what the name suggests, like take a copy of it and put it one side. It could be that I want to keep the changes. So like every day I want to make a daily backup, because if my computer crashes, that's it. So I could just do like a daily shelve. Or I can do a shelf because I did a piece of work that I'm not quite ready for. So I can say, don't preserve the changes. Take a copy of it, put it one side, and undo all the changes because I have something else to work on. There are a number of patterns surrounding all of this, right? So I'm just going to proceed with the check-in, and you can explore, you can add your work items, you can look at the different actions here, you can explore, but I'm just going to go ahead and check in. So once that check-in has been completed, if I go back to the repository on the server and refresh, now I'm seeing the project. So you see it's quite smooth. And in my opinion, yes, the wording might be a bit more clear than it is for Git, comparably speaking. But I mean, once again, pros and cons. There are a lot of teams still using TFVC, and you might prefer Git. But when we come back, we will look at what it takes to set up the build pipeline for a TFVC project. All right, guys. So in this lesson, we're going to be setting up the pipeline for our TFVC project, and we'll also take a look at how we can protect it against potentially harmful builds. So let's jump over to our pipelines tab, go to new pipelines, and once we navigate there, we can choose our location for our project, right? So our project this time is in Team Foundation version control. So we can select that, and then we can select our project, which is the only one we have. We can click continue. So from here, we choose the template. Given that we're dealing with a .NET 6 project, we're going to go with ASP.NET Core. But just like with the previous example, you can choose the template that best fits your application. And when that fails, you can build your own template with your own steps according to the type of projects that you are trying to build. So we'll go ahead with the ASP.NET Core template, which builds and tests an ASP.NET Core web application. So we can click that and select apply. And then we'll be given all the steps that it will carry out. But here we need to specify the agent. So we go ahead, and I'm just going to use Windows 2022, since that is the latest one at the time of this recording that goes alongside .NET 6. So of course, let your context be your guide, right? So I'll go with that, and I can save and queue. And once I do that, I can save a comment with this run. I can choose the source version. I can even choose a shelf set. So remember, we discussed what the shelf set was in the last lesson. But I'll leave all of these as default and just click save and run. And what it's asking me, let me... Okay, I'm not entirely sure why that came up just now. I just refreshed and then went back to the pipelines page, and here is the pipeline being run as we speak. And when we have all green ticks, we know that that was a successful build. So when I go back to the pipelines, I will now see that this has been built successfully. So let us look at some things that we can do to protect this particular pipeline. So for context, one, this is manually triggered. So it's not going to be triggered automatically when code is checked in. It means that every time I want to run it, I'm going to have to come here. I'm going to have to click on the pipeline, and then I'm going to have to say run pipeline, which is not really what we want, right? So if I go back to edit, I can select variables. So variables would be like default things, or I'm going to say settings, but default values, right? That's what I want to say. Default values that we want present in the pipeline. That's not unique to TFVC. I would have made mention of that from the previous pipeline activity, but I will jump over to triggers. Now for the triggers, here we can enable or disable continuous integration, and we can toggle gated check-ins. So enabling continuous integration means that the build will continuously keep track of each version, and it will retain previous versions and previous builds or previous artifacts, of course. So continuous integration, we can enable that. We can also look at gated check-in, so we can enable that. And then we can say run continuous integration triggers for committed changes. So that means each time there's a commit, do we want to add to that history? Scheduled, I can add a schedule. So when you hear a team talk about, oh, we do daily builds, this is all they really mean, that every day they take a copy of whatever is checked in, compile it, create an artifact, right? So they'll always have a publishable version of that day's version of the code. And to automate that, you can just schedule that daily build. So you'd usually want to schedule that when pretty much nobody would be at work. So like 3 in the morning, relative to whatever time zone you're in, would be good. And you can probably pause for the weekends. Now I'm going to revert that scheduled change, or that scheduled build, and we're just going to proceed with the enabled continuous integration and the enabled gated check-in. And then I'm going to save this. So what happens when I save this is that we know exactly what, let's say guards, right? Enable guards and CI. Just a comment so we know what change happened at this point. So with the gated check-in enabled, what happens is when I make a change in Visual Studio, and let's say I jump over to the index file of this project and I introduce some new code. So an H1 tag that says gated builds enabled, and save that. So obviously when I go to the Team Explorer, which is not visible right now. So once again, if you don't see it, you go to View, Team Explorer, and then it will pop up. You might need to reconnect. So I had Visual Studio closed for a while. So I'm going to have to manage my connections, reconnect to the TFVC project. And once that is done, I can go to pending changes and see the change that is pending. So I'm going to say testing gated build or check-in, right? And then if I check, it's going to now tell me gated check-in. You need to build your changes for validation before they can be committed, right? So a gated check-in is a wall of security now that's going to say, I am going to try to build your code. If I cannot build your code, then I will not be taking the code and placing it on the server. So that is one way that team leads can use to protect the integrity of the code base that the team has to subscribe to. So I can proceed and say build changes, and then it's going to say, okay, you can watch the validation from here. And then by clicking this link, it will bring me straight to the build process on the server. And the build completes successfully as expected. If we jump over to the repository, then the change that we just checked in, we should be able to spot it quite easily, right? Testing gated check-in, just now checked in, and there's our change. So let us see the real reason you'd want to gate your check-in. So after that, what you'd want to do is reconcile your workspace so that it knows that these are no longer pending changes. And that's one thing that I've noticed with TFVC. If you fail to do this, then the next time you're checking in, it might get confused between seeing the new files and the old files that it probably has an idea that it checked in already. So you want to just reconcile your workspace so it just knows, okay, after everything was successful, I can now demote that particular file from the included changes. Now let us break our code, which is the real reason you'd want to do a gated check-in, because you don't want persons to do anything untoward. So I'm just going to put gibberish, right? This could easily be some legitimate syntax error. And let's say the developer did not do Control Shift and B to actually build it in Visual Studio. They thought they did well. They probably left off a semicolon on a line and did not notice. It could be a genuine error. So at this point, I'm going to save the file with this obvious error or this error, right? And now it's telling me that I need to check this in. So testing error with gated check-in. That's my comment, right? So I'll check in. Yes, I want to check in one item. Yes, I want to do the gated build. And then let's jump over to the build details again. And then if we watch the process, we will see a red X, which is bad. If we click the red X, then we're going to see that it's telling us which line it detected an error on, right? The error here that we're going to see is really the same kind of error that we would be getting in Visual Studio. So it's just telling us that there's an error, and so the build failed. All right. If we check the repository and look in that very file, which was the index code file, you see here that the latest check-in was still the one that I did prior to this one, right? So this file has not been corrupted with our bad code. And in Visual Studio, you are going to get the visual cue that lets you know, hey, something happened, right? So you can always click and view build details, which will just bring you, to the log of the build that has failed. So that is how you can go ahead and protect the integrity of your code base with a gated check-in. So when we come back, we're going to look at how we can go about doing similar or carrying out a similar protection, but with our Git builds. All right, guys, so we're going to look at what it takes to set up a release pipeline. We looked at it, but we're going to be doing it this time and with a bit more scrutiny. So what I've done to get through this activity easily is I've disabled the security that we would have put on the branch earlier. So just as a recap, on the main branch, we had put on some policies where we would require the minimum number of reviewers as well as build validation. So I've disabled those right now so that everything can work a bit more seamlessly for this activity. So when we want a release pipeline, we go to pipelines, which of course would show us our build pipelines, and then we would go to releases. So I already have a release here, and I'm going to delete this one. If you have it there, you can also delete it. And of course, as usual, we have to make sure that we are clear on what we're deleting. So now we have absolutely no pipeline. So let's start from scratch, right? So to create this release pipeline, we are going to firstly click new pipeline, which will give us this kind of wizard. First of all, we need to select our template. Now, I think by now we've seen that this tooling is not unique to .NET development. You can set up build and release pipelines for almost any development environment. Ruby on Rails, Azure-based services, anything physical, you have a number of options. So to get through this particular activity, we're going to do an Azure app service deployment. So that means I'm going to have to go onto Azure, set up an app service, and then it means that every time we do a build, it must deploy automatically to that app service. So I'm going to apply this one, and then it's going to ask us what we want to call that stage. I'm just going to call it deploy to Azure app service. So remember that this is the pretty name that goes here, right? And we can move ahead from there. So I need to select an artifact. The artifact is the set of files that represent the version of the application that is about to be deployed. So I'm going to say add an artifact, which can come from any of these sources or more. So we can use an artifact from Jenkins, which is a very popular build tool in the industry. We can use GitHub, which has very similar capabilities. So here it's not necessarily centralized to only Azure DevOps build pipelines. We can look at third-party tools, even Docker Hub, and as I mentioned before, GitHub and other Git-based repositories elsewhere. We can look to those build tools and get the artifact accordingly. For now, however, we are using the build. So we're going to say, look to the build for this project and what should I use? So here we have two builds. We have the one that was for the TFVC and we have the one that's for the Git. I'm going to use the Git build pipeline. We want to use the latest, but we could always deploy a specific one or one with tags, etc. So, based on what you need for that in particular environment to which you will be releasing, you can choose whichever one is most appropriate. We'll just use the latest and I'll click add. So here we're setting that, yes, get the artifact as the resulting deployment set of files from this build or the resulting packaged set of files from that build. We can also set up daily releases or just schedule them, right? So we can say create a new release at the specified times. So another part of a daily build would be like a daily release, right? We compile our code every day and we also update these environments every day. So you'd probably want to do this for like the dev and the QA environment so that by the next day, if anything made it past all of those quality gates and still got deployed into the environment will show that result of something going wrong, right? Once again, context. So I'm not going to schedule that, but another thing that I want us to look at is the continuous deployment trigger. So if we click that lightning bolt, this is where we can enable continuous deployment. So that means always do a release every time a new build is available. Once again, context. I know teams where they don't necessarily do this part. So they instead schedule it because you might have multiple check-ins or commits during a particular day, which would trigger multiple builds. And then, they probably don't want the environment updating that frequently in the middle of the day. Context once again. So in this demo, however, we are going to look at what it looks like for continuous deployment, because this could be like for a QA or a production branch where clearly we are going to make sure everything is pristine by the time it gets to a build. And once the build is successful and all the other checks are gone through, go ahead and update the environment. That could very much be the situation that we're dealing with. So I'm going to enable it in this situation. And you'll also see here that you could enable a pull request trigger. So this will create a pull release every time a selected artifact is available as a part of a pull request workflow. So you have your various options. So I'm going to work with the build trigger for now. So you can click that off. And now we have that continuous deployment trigger. So we looked at continuous integration, which is continuously keeping a copy of the new code. And then we have continuous deployment, which means every time there's new code, let us deploy it. In the next stage, we want to look at the tasks that are in contention. So we can click here, or we can click the tasks tab up top. And then here they're saying, okay, you want to deploy to Azure, so you need your subscription. So I can select my subscription. If yours isn't there, maybe by the time you click this or you click manage, you will be able to authenticate and select the subscription that you are working with. So I'm going to select my subscription, and of course I have to authorize it and authenticate. And once it is satisfied, then it will allow us to continue. So the app type, I'm going to leave it as a web app on Windows, but here you see all of your various options. It could be an API, it could be a mobile, it could be a function app. So you can check out my course on Azure Functions and how you could develop a whole API using just Azure Functions. I have a course on API development, which also kind of walks you through this. And I do have a course on web app development, so you can check that out as well. So we will proceed with the web app on Windows, and then the app service name we are allowed to choose. So here are some app services that I have on Azure right now. I don't have an app service that I've created for this particular activity. So what I'll do is jump over there and create it. All right, so I'll just quickly cycle through this. If you're not familiar with how to create an Azure account and set up a web app, you can check out my course on Azure for .NET developers. So I'm just going to cycle through this relatively quickly. I'm going to give it a new resource group that I'm going to call School Management Demo, and give it a name. So I'm going to call it School Management App. All right, no special characters, School Management App. I'm going to publish code, and the runtime will be .NET 6. Leave it at Windows. I usually use the East US 2 region, and I'm going to leave it on the same plan that I have running, which is a free tier. So if you're on the free tier, then this should come at no cost to you, and then we can review and create. And once that's provisioned, I can go to resource and just to verify that it's there. So when I jump back over here and I refresh, then I will see School Management App. So that is where I expect it to deploy to. So for context, if I browse to that app that has just been created, fresh off the boat, that's what it looks like. All right, just a default page. So it is just waiting for me to place files there. So I'm going to save this, and I'm going to just say setup release pipeline. Okay. And then I can manually trigger a release if I need to. So from the all pipelines or the releases, I can actually see the pipeline and trigger it. And here it's called new release pipeline. I don't like that. I'm going to edit that. So I can actually change that up here, right? So Azure app release. So, oh, I'm sorry. Let me save. There we go. I could have said change name as the comment, but just to verify now, I can see clearly what this release is. So this is how you'd want to name your releases so that you're clear as to what environment, maybe what stack, or what application this release is relative to. So once again, I can create a release manually. So I'm going to do a manual release right now. And then here it's just verifying that it's going to run that particular stage. I can actually disable a stage. So the thing is that, let me jump back to the design of this pipeline. These stages are really like quality gates, right? So I could set up stages to say, maybe the solution had multiple projects, like some services that needed to be deployed. So while it's one solution, it has multiple projects and each project has some interdependency. So I probably need to deploy the API before I deploy the UI, before I deploy a Windows worker service, all of those things. So each stage could represent something that I need to do as it's doing the deployment. You could do one after the other because you could add stages, right? And you can chain them along. So after you deploy to Azure, then what do you want me to do? And you can even say, like, I want some to happen kind of simultaneously or in parallel. And to do something like that, I would have to go to the pre-deployment conditions, which will allow me to change different things. Like I can put on filters. I can choose to schedule a particular task outside of scheduling the whole release, right? I can do pull request deployment on a particular task. And once again, a task here would represent which project or which particular part of the solution it is that you are deploying to a particular place. I can do pre-deployment approvals, so I could enable that only certain persons can approve a release. I can set up all of those things from this particular area. I can put on gates to ensure that certain conditions are met before it can go. So I could invoke an Azure function, something along those lines. So you can use those options according to your particular situation and how you want to govern your release pipeline. But the deployment queue setting, it can say define the behavior when multiple releases are queued for deployment. So how many should or could happen? Do you want only one parallel, or do you want unlimited? Do you want to deploy in sequence? Do you want to deploy latest? So you can actually change the order or kind of have parallel tasks as part of the release. So I'm just keeping it simple with this example. I'll just save. Once again, that's all that we want to do. And then I'm going to trigger this release. So I can just click create release manually. And I think the point I was making was that I could actually disable. So what if the whole solution was there with multiple tasks, but really and truly in this situation, I just need to release one or to one environment, one part of the entire solution. I can actually tick and untick the ones that I want to do manually. So here I'm doing it manually. All of this is not ticked. So this is saying that all of that will be done automatically. So I could actually tick the one I want to do manually, right? Anything that's not ticked will be automatic. So I would actually tick everything and say I want to do all of them manually. And then if I tick that, go to create, what it does, it creates the release, but nothing is really going to happen because I said I want to do it manually. So okay, oh, that's nice. They made big improvements. Thank you. So now what it is showing me is that the release has been created, as in the history of the release has been created, but nothing is being done because I said I wanted to do the step or the task or the stage manually. So at this point, once again, just work with me. If I had multiple stages that should happen when this release pipeline is triggered, I said I want to do all of them manually. Now I can cherry pick which stage I want to do. So if all I wanted to do was release a quick sentence fix to the website, I didn't need to rebuild the API, re-release everything. But of course, when something gets checked in, everything gets built, but I don't want everything to be released. I could easily just come to that particular step or stage and say, only deploy this. So this is the only one that I want to deploy. Go ahead and deploy, and then it is going to get queued up. The same agent that does our builds is the same agent that is going to be handling our deployments. Now, you would also notice that this might take some time, right? It's 5 minutes remaining. The thing is that because we're using the hosted agent, we have shared resources, and that's what we get with the free tier of Azure. We went through how we had to make that request and how we were granted access to the hosted agent, and that is why you might not get that speed. So when you have your own tier that you are paying for, you can actually go and get more agents. You can create your own custom agent that will take over your builds and your releases almost immediately without having to sit down and wait on your slice of the resources. All right, so when that finally gets started, we can jump over to the logs and watch what is happening. So you see here, it went through, and let me just go through the agent logs, deploy to app service, and we can just look at a summary of what it did. So all of these files are project files that would have been in the deployment set of files if we had done this manually, right? So everything got deployed, and then it is saying here that the application URL is at this location. So if I control click that or jumped over to our dashboard and browse to it, then we see here, this is our web application, right? So that is the same URL. So this is what it looked like before. This is what it looks like now. And in case you think I'm probably giving you a 6 for a 9, let me refresh this page. And now we see what we have deployed, right? With all of our little quirky comments about new features and main branches and everything. So that is how you can set up a deployment pipeline to deploy directly to your Azure space and update your application. So I'm going to do one more example. That was a manual release that we just did. All right, guys, so last video we did it manually. Now we want to test how the pipeline actually works when a modification is made to the code and it is committed, how the build works, and then how the release happens automatically. So I'm going to do a simple code change from right here. Make sure that we're on the main branch, and I'm going to go over to index, and then I'm going to place that line right there in that index file. So any change you make, that's fine. Remember to click edit, of course, make your change, and then you save. Once we save, that triggers our build job. So that job will run through build. We know what the build pipeline does already, so it will create that. So you see here that I had to make 2 attempts because for whatever reason, the first time actually timed out when trying to communicate with the NuGet servers. So I had to try it again. That's fine. So that's a cool thing about builds. When they fail, you can actually rerun them, and then they will just pick up where they left off, and then they will try to get it done. Now, after that build pipeline is completed, it should trigger the release. So when I jump over to my releases page, I'm seeing that I had a release 2 that failed. So I actually flagged it as abandoned, right? Or I chose to abandon it. So it failed. And then I went to the release. I could view the log. And what the log told me was that it failed to connect to the resource on Azure, right? Not entirely sure why. I suspect it's a limitation with the hosted agent and how quickly I was trying to do a release between time. So I think that's why there's that limitation that existed. But you can always view the logs and see as many details as possible. And I was able to come up top here, and the option was there to just abandon, right? You could also try to manually deploy if it failed. So the same way you can rerun the failed pipeline is the same way you can choose to redeploy. However, I didn't want to do a manual one. So what I did was I made a tiny change again in the file so that it would trigger the build. So if you look in the pipelines, you'll see that I had another build after the previous one that I just showed you, right? So I'm just full transparency here, right? So this is that build, and then it triggered the release. So let me show you that from the build, I can actually select that and then go over to the releases side and see the release associated with that build, which is release 3, which was a successful deployment. So when I refresh my deployed website on Azure, what should happen is that I should see a new H1 tag. And there we go, targeting release pipeline, or testing rather, release pipeline. So that is how you can almost inconspicuously keep your web application up to date. If a user complains about something while they're on the website and you get the complaint, you set up the work item for the bug fix, the developer can do it. All of that probably, let's say, can be done within 2 hours. You can easily release your bug fixes and your changes after they've gone through your appropriate quality gates, of course, and the user would actually probably not even notice that the website updated right before their eyes, because between clicking on pages, that website would actually get redeployed, and the most that they would endure is probably like a longer load time than they're used to when normally navigating the website. So that is how you can automate these releases. And there are a number of things like if we go back to the release and click edit, we see here that there are things that I didn't point out. So we spoke about the tasks. You can add more artifacts. So you can say that when this is released, I want to also release from this other project, from this other build, from this other source, etc. So you can have multiple artifacts, and each artifact can have its set of stage or quality gates associated with it. You can set up variables. So here you would want to set up like pipeline variables, which would be like constants, maybe like names that you want to use throughout the pipeline, or other values, maybe file locations or web locations, etc. You can set up variable groups accordingly, right? So if I click pipeline variable, I can say the name of the variable, the value, and then the scope. So is it a release scope, or is it within the scope of just the task that is being carried out at that particular point, right? I can set up predefined variables, and you can always go to the reference documentation to see what those predefined variables can be and how you can use those values. You can also set up retention. So I can say that I want to keep this release for up to 30 days and only 3 at a time. Of course, the policy may vary for different branches. So maybe for a dev branch, you wouldn't have such a huge retention policy, but for a production branch, you would, right? You can change certain options, so you can do other integrations, right? You can report deployment status to work, boards, to Jira, etc. And you can view the history of the entire pipeline, who has modified it over the period of time. So there are a number of things. A lot of these are really for auditing and security and basically checks and balances. But at the end of the day, you will be using certain settings. You might not be using certain settings based on your situation.